Okay, so we're going to have a go at solving a few AASL questions which are familiar with us from our course for IM3. Our first one here is, this is a typical question we might get asked on our exam. So in the expansion of x plus k to the 7, the coefficient of the term in x to the 5 is 63. Find the possible values for k. So I need to pull up my formula sheet and find the formula for binomial expansion, and that's going to give me NCR multiplied by the first term, which is x, to the n minus r, multiplied by the second term, which is k, to the r. We need this to equal 63x to the 5. The term in x to the 5 is equal to 63. So that means, firstly, it implies that n minus r is equal to 5. So we know the value of n, it's given as 7, so 7 minus r is equal to 5. This tells us that r is equal to 2. So we then need to find the binomial number, 7c2, which is given by the formula n factorial, n minus r factorial, r factorial. And that's going to have 7 factorial over 7 minus 5 factorial, 2 factorial. So this is 7 times 6 times 5 factorial over 5 factorial times 2. And the reason I've left these two 5 factorials is they'll cancel each other out, saving me a bit of work. 6 divided by 2 is 3, so 3 sevens are 21. This is 21. So that tells me then, I've got a few bits and pieces worked out now, that 21 times x to the 5 times k to the 2 is equal to 63x to the 5. So cancelling through the different terms, cancelling a bit here, that one cancels with that one. This 21 is going to cancel this one down to a 3. So what is the value of k? K can be plus and minus root 3.
Can you just use the pyramid to find it instead?
Yeah, you can use other techniques and strategies. You can use Pascal's triangle. You can draw up Pascal's triangle on your page and show how you're pulling off the...
If I drew it like not in the box, would it be graded?
It should be drawn in the box if it's part of your method.
Sorry? Is it okay or calculating if we just discarded the x because we're just trying to find the coefficient? What equals to
Yeah, so that's what I
There's a few different ways to structure your paper, but this is the basic technique and strategy you can use. All right, so our second one, the function f is defined. We've got a rational function given here. We've got a little sketch just to help us on that one, see how it looks. Write down, give myself a bit more paper. There we go. Okay, so firstly, write down the value of f of 0. F of 0 is this point here. F of 0 is this point here. With an IB question, very, very specific on the key terminology. And you'll see that we use those in our IM courses as well. Write down means no working needs to be shown. Write down means you don't have to show any working. Find means you do have to show working. And if you don't have your working, then you won't get the points. So our first one is A. We have to write down the value of f of 0. So I can do this in my head if I want. I don't have to show any working. Just go back up there. So if I put a 0 in here, that's going to cancel. Put a 0 in here, that's going to cancel. So it's minus 2 over 1. So it's going to be minus 2. That's why it's a write down. So f of 0 is minus 2. Write down the equation of the horizontal asymptote. Just again as well, the strategy there for this one is with this function, when x gets to be really, really large, let's say x gets to be closing towards infinity, we have 3 times infinity minus 2. That minus 2 is meaningless at this point. When x becomes a really large number, plus and minus 2 is going to make no difference to it. A massive, massive number, you take away 2, you won't see any difference. So that means it would cancel to 3x over 2x. Now, if the x's are the same, then they cancel as well. So as we go towards infinity with really large numbers, the 2 bits there at the end cancel, and the rest just simplifies down to this.
Sorry?
So you would see that the horizontal asymptote would be y is equal to 3 over 2. For this type of a question, if you wrote 3 over 2, you would get no points. It says clearly write down the equation of a horizontal asymptote. If you don't have an equation of horizontal asymptote, you will get no points. If you write something to do with like a range of the function, y is not equal to 3 over 2. Often with vertical asymptotes, people confuse the vertical asymptotes with the domain of the function, which is written with a not equal sign like this one. And if you do that, you will get no points. It must be a correct equation.
So the way I found it was that I divided 3x minus 2 by 2x plus 1, and then the top, I forgot the name, the top thing would be
Yes.
equal to 3 over 2.
With all mathematics courses, any valid method is appropriate. You'll still get the points. If you use polynomial division for this question, you're wasting time. So you don't actually get penalized on this question, but you will get penalized on your time. So not selecting the right, most efficient method will cost you in the long run on your paper. Not there on that question, but you'll lose time. No.
So like if it's a bigger equation, I shouldn't use that one.
There are multiple ways to solve math problems. Any valid math problem is perfectly acceptable. Generally, as we get better at selecting the shortest cut methods or the most appropriate methods. But when we get stuck and we need to go down some pathway, we have to go that way. It's better to have a full understanding so that we can, in different situations, we can take different approaches, and that's why we look at different methods. All right, moving on. The function g is defined by this, and f. G of x is minus f of x. So what type of transformation is this?
Reflection. Last. Over the x-axis.
This is a reflection over the x-axis. So we've actually, and then we need to find, we need to find for the domain x is greater or equal to 0, we need to find the range of g. So we've actually just figured it all out in the last question. We've got that horizontal asymptote of y is equal to 3 over 2. And we're taking, oh, that's okay. We're taking this section of the graph, and then we're turning it upside down. So that was there. So what's going to happen with this section of the graph is it's now going to be flipped to here. It's going to come and look like this. This will be y is equal to minus 3 over 2. The coordinates at that point were 0, negative 2. So the coordinates at this point are going to be 0, 2. So the range is going to start off, are we doing range yet? The range is going to start off here at negative 3 over 2. It won't include that because that is an asymptote. And then we will go up to and include the y-intercept of 2. So we get this.
Why does it only go to 2?
That's the one.
Because the domain has been restricted to greater or equal to 0.
If I wrote an internal form just over it,
Sorry?
internal
Oh,
form.
like it doesn't go in this.
Well, any appropriate form is fine. In interval form, you could write this one as minus 3 over 2, comma 2, and you can use set notation as well. And any suitable mathematics is suitable. There's nothing in the question that says use an inequality to describe it.
What are the 3 marks for? What are each of the 3 marks?
Oh, we can look it up if we look at the mark scheme. Let me just open up the mark scheme. So I've shared the mark scheme with you on the Google Classroom. Let me just open it up again. Bring it over here. Okay, so for this second question, let's have a little look. So yeah, we needed -2 for that one. It would accept a coordinate. We got the equation here. It says it must be equation. Don't accept this sign. And the first one would be an attempt to reflect the graph in the y-axis. So if I'm marking myself, my sketch here is going to get me the points. And it says attempt to. So if you don't have the correct graph, but it's clearly obvious you're trying to reflect it in the y-axis, in the correct axis, you will get the point. So look at the wording of the question here. It says attempt to reflect the graph. That means that as long as the examiner can see from your working that you understand you're trying to reflect that graph in the thing, let's say you didn't restrict the domain, you reflected the whole graph, you'll get that first point.
Will I get a point if I like state that one part of the range is -3/2?
Typically what the examiner will do is look at the name of the person at the front, and if it's a student that bothers him, then on these sort of grey areas, no. But if you like the kid or that's attractive, then you will give them a point.
So I'll give myself a point, yeah.
No, I would not give the point. Okay. What did you write?
I just said the negative of x, like the y equals -3/2.
So if you're getting 3/2, then I'm going to give you 1 point.
All right.
You're going to get 2 points. So it's -3/2, so you get 2 points. It's a good question. So, oh no, wait, 1 point.
Yeah.
Isn't it?
No, it's 3. Yeah, there must be a little thing missing here in the mark scheme. There must be a thing missing in the mark scheme here like this, because it is 3. So 1 point, if you have one value correct, like you have in this one, you would get the first point. So you either reflect it in the graph here for 1 point, or you have one of the values I've seen on the page somewhere, and that gives you the second point. If both of the values are seen, then you're going to get a point. And thirdly, if you have the correct inclusion-exclusion, that would be where the third point is coming from.
So if I said that y would be bigger than -3/2 or smaller than -3/2, then I get 1 point? Because I didn't limit it.
You're getting 1 point.
Yeah.
Okay, where are we? We are back here again. Let's have a go on. Next question. Okay, so we've got some trigonometry happening here. Following shows for triangle 6 and 8. Given that the cosine of A is 5/6, find the value of sine A. So this is a standard procedure. Definitely, I like to ask this one on our exam. It's a question I like to ask. What you need to do here is there's a couple of ways to solve it. The best way of solving it is with the Pythagorean identity. So using the Pythagorean identity, we get that the sine of squared of A plus the cosine squared of A is equal to 1. So I would stop here. I would put in our different values. We get 25/36. Turn this into something over 36. And then we've got sine squared A. Moving these around, we get sine A is equal to square plus or minus the square root of 11/36, which is equal to plus and minus the square root of 11/6. Now, this is in a triangle this angle A is clearly in a triangle, which means it is between 0 and 180 degrees. So we can say that as A is between 0 and 180 degrees, it implies that sine A must be positive, which means that sine A is equal to root 11 over 6, and it's not equal to the negative of 2. That's not going to happen in a triangle. The cosine value can be positive and negative in a triangle, but the sine value must be positive.
Do I have to explain it?
Yeah, it's good math.
Let's say I don't understand, but I still take a point, but I say different answer.
I'd have to check the mark scheme. Probably at SL you'd get it, at HL you wouldn't.
Like if I just put square root 11 over 6 without putting plus minus in the start, like just that.
At SL you'll get your point,
Okay.
at HL you won't. B. Find the area of the triangle. Area is equal to a half AB sine C. So that's a half times 6 times 8 times the sine of A. The sine of A we've already worked out to be root 11 over 6. This cancels down a lot, so we get 4 root 11 area units. Oh no,
Look at the one.
does it give it,
minus-
does it tell us the units?
No.
No, area units.
Reflected equals to-
Okay, that is it for that one.